Really quick, I'm gonna flip a coin and I want you to guess either heads or tails. Ready? And now, it was heads. If you guessed right, congratulations. You can thank hashtag Blessed RNG. Who's that? You mean, what is that? Let's take a moment and talk about it. Hello, 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 and welcome back to Moment of Zen, a podcast about everything and nothing. I am your host, as always, Jonathan Zen. And again, thank you all so much for your support. Keep those ratings, reviews, comments coming in. So this week's episode is going to be a little bit shorter than normal, and I apologize for that. It wasn't my intention that it would be shorter. It just so happened that today's topic is a little bit shorter than what I normally talk about. So hopefully that's all right with you. And if so, let's begin. Let's go back to that coin flip I just did. I'm sorry, but I lied to you. I didn't actually flip a coin, at least not a physical coin. I mean, I pay everything with my credit card, so I don't have any coins lying around. So if I didn't flip a coin, then how did I get heads? Easy. I asked Google to flip that coin for me. Go ahead and try. Just type flip a coin in the Google search bar and it'll do it for you. And don't worry, I'm not going to be spending the next 15 minutes talking about flipping a coin on Google or all the cool little tricks you could do on Google. What I do want to talk about is something most people don't really think about, at least if you're not a programmer or a gamer. If you are a programmer or a gamer, then from the title of this episode, you probably already know what I'll be talking about today. But for the rest, ask yourself, how do you think Google decides how its virtual coin is flipped? In real life, when we flip a coin, we expect that there's a 50-50 chance that the coin will either land on heads or tails. If we just program the Google coin so that it shows heads half the time and tails the other half of the time, we've made that Google coin, right? Well, not exactly. I mean, if you did it that way, the coin would just alternate between heads and tails every flip. The predictability of the coin flip pretty much defeats the purpose of flipping a coin in the first place. What's the point of flipping a coin if you know that after you've flipped heads, that the next flip will be tails? If we wanted to make a program that accurately replicates what happens in real life, then we've failed. Real life is not perfectly ordered or always predictable. For the most part, our lives are predicated and dependent on sheer chance and randomness. I think not knowing what's going to happen tomorrow or even in the next few minutes makes life much more interesting and exciting. Whether you believe in free will or determinism, that doesn't really matter because either way, you can't predict every little thing that's going to happen in the future. You can try and guess what will happen, like with a coin flip, but ultimately, it's almost impossible to really know what the outcome of the flip is and the outcome of what your future is until you actually get there. Or in terms of the coin, you won't know what you get until you actually flip the coin. And if we go back to why our coin flipping program failed, it failed because it doesn't account for the randomness that we experience in our everyday lives. You see, a computer is extremely orderly and predictable. If you give it a set of commands, it will do exactly what it's told without question. There's no inherent randomness in computing. That's just how computers are built. It will always predictably spit out a combination of ones and zeros whenever you give it a command to do so. And if that's the case, then why is Google able to create a coin flipping program in its browser? Well, I said that computers inherently don't have any randomness built into their code. We humans, or at least human programmers that created the computer, we gave them life. We're basically the gods of computers. And like the biblical God, we have a son, and his name is RNGesus. So now that I've offended all of my religious listeners for blasphemy, I just want to say that first, let me explain. I know we're not actually computer gods. Well, at least most of us aren't. So, what is RNGesus? It's not actually a person. It's, and I'm a little ashamed to say this, but RNGesus is actually a meme. It's a meme created by gamers, and I don't know exactly who coined the meme, but it's mostly used in the gaming community. And to the gamers out there, I'm sorry, but today's episode isn't going to be about gaming. I'll probably save that for another episode. But instead, this episode's going to be talking about the importance of what the RNGesus meme represents, because it's much more than just a gaming meme. The origins of the meme is incredibly important to not only gamers, but also to other things like your online security and scientific research. So if you take the first three letters of RNGesus, you get one of the most important applications of any coding language, which is RNG, or random number generator. RNG. Why is it so important? If we go back to our coin flip example, our coin flipping program failed because it lacked randomness. In real life, we don't expect to get tails right after we flip heads. It's random. So to create randomness in our computer, we use what is called a random number generator. And how a random number generator works on the surface is really simple. The computer just randomly generates a number. A simple way to code our coin flipping program is to write out what is called a conditional statement. If you don't know coding, then don't worry. This statement is a basic example of what a conditional statement is. To simplify what I just said, let's just say for the sake of simplicity that your random number generator can generate a random number between 1 and 100. Then all you need to do is write a conditional statement that says if a number that the computer generated is between 1 and 50, then the coin is heads. Else, if the number that the computer generated is between 51 and 100, the coin is tails. Obviously, this is an extremely oversimplified way to create randomness and chance in a simulated environment. But for a simple coin flip, this code logic is sufficient. For much more complicated applications, of course, there will be much more complicated algorithms and probability equations to create simulated randomness in a computer. Online gambling, which is a multi-million-dollar industry, relies almost exclusively on RNG, especially for their card games or slot machine programs. Gamers know all too well that certain item drops or damage calculators or spawns also rely on RNG. Aside from gaming, RNG is also used a lot in research to introduce noise or randomness to a perfect simulated environment. And it's also a very important application of security. I'm sure one way or another you've probably heard of online hackers stealing passwords to emails, social media accounts, gaming accounts, or whatever online account there is. This is a very important issue and topic, and I'll probably talk about online security in another episode. But to stay along with the current topic of RNG, RNG is used to protect us from potential hackers. It's used in something called encryption. Basically, what encryption is encoding or rewriting a message so that the intended recipient can read the message. Think of it like when you were younger and you wanted to pass maybe some notes among your friends, but you didn't want others to know what you were writing, so you wrote your messages in a code that only you and your friends know. That's basically what encryption is. And of course, encryption is much more complicated than just rearranging the letters of the alphabet to create your message. And to kind of stress the importance of how RNG works to keep your passwords safe, let's go over some really bad ways a programmer can design a website. For those of you who aren't tech savvy or know a lot about computers, when designing a website that requires you to create an account for that website, one of the things that the programmer needs to do is write a code to store your login details like your username and password. Let's take Google for example. If you have a Google account or Gmail, your username and password is stored somewhere in Google's server. So when you log into your Google account, there's a piece of code that checks your username to make sure that it's in the server. And if it is in the server, then it looks at your password and it makes sure that it corresponds with your username. So if both your username and password check out, then you're able to log in just fine. If not, you'll get an error message. Well, on the outside, it's pretty simple, but what exactly happens on the inside? Your password, which is the most important part of your account, how is it stored in the website server? The easiest way to store it, and of course the most unsecure way to store your password, is plain text. I can't stress this enough. If you're learning to program or create websites, this is the absolute worst way you can store a password. It may seem really obvious, but there's a reason why I'm stressing this, and that's because there are websites that do indeed store your passwords as plain text. And if you don't know what plain text is, it's basically if your password was I love cats, no spaces, then in the server where your password's stored, it also reads I love cats. So what's so problematic with this way of storing your password? Well, if that website gets hacked, the hacker will be able to look at your username and the corresponding password associated with that username, and they'll be able to access your account extremely easily. A much better way to store your password would be to encrypt your password before storing it in the server. What this does is use an encryption key to replace the characters in your password with completely different characters. So instead of having I love cats stored in the server, what is stored is something like E41JAK86. This way, if a hacker hacks the website server and looks at the account information, he won't be able to see your password in plain text. Instead, he'll see E41JAK86 or whatever your password is encrypted to. Of course, how your password is encrypted will depend on the programmer. The worst way to encrypt your password is having a direct translation from plain text to your encrypted password. And what I mean by direct translation is, let's say the letter E becomes replaced with the number 7, and the number 6 is replaced with capital P. This isn't the best way to encrypt passwords, since once you crack one key, everyone else's passwords will become compromised as well. The best way to encrypt a password, and the majority of websites nowadays use this method, is through an encryption key that uses a random number generator. And I won't go into specifics of how the encryption key works because it's very complicated. And to be honest, I don't really know how it works either. And it's a good thing I don't really know how it works. or that a lot of people don't know how it works because that's how it becomes safe. The gist of how it works is that the key will take your password in plain text and put it through this long and complicated encryption key algorithm. It'll randomly assign different characters of different lengths to your password. So if your password I love cats is 9 characters long, it could be stored as a 16 character string. And the best part is that if someone else has the same password as you, I love cats, when their password gets put into the encryption key, it could spit out something completely different from what your encryption key spat out for you. And that's because it uses a random number generator to randomly assign these characters to those passwords so that no two passwords are the same, or no two encrypted passwords are the same. And even if they are, their decrypted passwords can be completely different, which will throw off a hacker if a hacker is able to hack into that website and look at your username and password. He won't be able to guess what your password is unless he has the decryptor, which is a topic for another day. But of course, this is an extremely simplified summary of how password encryption works. I just don't have the time to go over every single detail, and like I said before, I don't know every single little detail. And just a little quick fun fact, if you look at your URL address bar on your browser, secure websites will have a little green lock right before the start of the URL. If you see that, then you can be sure that your account information on that website is encrypted and secure. Though what the website does with your information, that's a topic for another day. Just saying. So now that you know about the great uses of RNG, how does a computer actually generate a random number? There are one of 2 ways a random number can be generated. The first way to generate a random number is through physical noise like thermal or atmospheric noise. And what I mean by noise isn't sound per se, it's simply the imperfections and inaccuracies of measurement. So when you measure temperature, you can never really get a perfect reading on a thermometer. Take room temperature, which is about 73.4 degrees Fahrenheit or about 23 degrees centigrade for the rest of the world. If you have a super precise thermometer, you'll notice that the thermometer will read something like 73.3989 degrees Fahrenheit, and the next second it'll be 73.40001 Fahrenheit, and the next it'll read 73.3397, but most people will say it's 73.4. And these fluctuations are what are used to generate that random number. And these kind of fluctuations are what we call noise. They're what are used to generate that random number. So this is called a true random number because it actually uses something physical to generate the random number. This is not practical because if you look at your computer or your phone, you'll notice that there isn't a physical instrument measuring naturally occurring noise. Instead, what most computers do to generate a random number is through a random number generator algorithm. And because the random number is generated through an algorithm, it's technically not, quote, random. I know this seems like a big lie, but it's true. The majority of RNG isn't truly random. And to be more technical, most RNG you encounter is actually what's called pseudo-random numbers. But the algorithms that you use to generate the numbers are just so well done that for the most part, they are considered truly random. There are a ton of different methods and algorithms out there to create a random number generator, and you can definitely take an entire semester college course just on the intricacies of making a random number generator, but we don't have time for that. So instead, I'll just go over a really simple example of a very simple but for the most part effective way a random number is generated. So one of the easiest ways to create a random number generator is to base your RNG on time. So if we take the current time, let's say May 15th, 2017 at UTC 12 o'clock, we can convert that into Unix time, which is the number of seconds that have passed since January 1st, 1970. And if we do that, we'll get a huge number, which is 1,526,126,400 seconds. And what we can do with that number is put that number into an RNG equation of some sort, and it'll spit out a random number. Since the number you put in the equation is based on time, every time you use the RNG equation, you'll get a different number. And of course, the obvious drawback is that if you manipulate the time on your computer, you can get the same number if you change the clock into a specific time. But for simple random numbers, this is more than enough for most people. If you need something that produces a much more truer random number, a much more complicated algorithm and or method is required. And there you have it, one of the most important computer applications you probably didn't know about. So next time when you're playing an online game or typing in your password, remember to thank RNGesus for keeping you safe. And with that said, thank you all so much for tuning in. This has been your Moment of Zen. Until next time, take care and stay fresh. See ya!